Okay po, as a continuation nung ating inaaral last time. So here, I want you to have a basic knowledge po about sa electric field or sa electric flux po natin. So, if I have a positive charge dyan, so yung positive charge ko is para siya nag-e-emit ng electric field na outward. Na yun, radially outward. So, ibig sabihin kung may positive charge ako, ang electric field ko is outward, going away from my charge. Parang ganyan. So, radially outward. Kapag naman po siya ay negative, so if I have a negative charge, yung electric field ko naman is going inward. So, tatandaan niyo po, mabuti yan, radially inward at all areas po natin. Okay? So, ngayon, if I have, just for us to remember also, if I have an outward electric field, yung flux ko din is magiging outward. And kapag outward yung flux ko, it would always be positive. Ngayon, if inward naman po yung aking electric field, so inward din po yung aking electric flux, and my electric flux will be negative din po. Okay? So, ngayon, ayun, parang ganyan po siya. Let's talk about long wires. So, what if I want to find the electric field in an infinitely long thin wire? Okay, so kunwari daw, I have a infinitely long thin wire na meron siyang yung charge sa kanya is uniformly distributed, meaning equal po yung kanilang distribution. So find the electric field using Gauss's law, and the charge per unit length is lambda, which is assumed positive. And please do remember, if the charge per unit length is assumed positive, then my charge would also be positive. So sabihin natin, mag-drawing tayo dito guys ng infinitely long. Sabihin natin na, okay, ayaw niya. Kunin ko lang po. Pen. Yeah. So, this is an infinitely long thin wire. Kunwari, kaya siya infinite kasi nga, wala siyang katapusan. Okay, ayaw niya. Ayan, infinite. So, isipin niyo na lang na pantayan. Okay, and then, yung charge daw sa kanya is positive and it is distributed uniformly. Pag sinabing uniformly, equally space, equal po yung dami ng charges per unit length po natin. Okay, so hindi natin alam. Since, if you remember, yung sinabi natin kanina about positive charges, the electric field of these charges are always outward. Sabihin natin may electric field going that way, electric field going this way, and this way also. Diba? And kung mapapansin nyo sa drawing natin, yung electric field natin is also constant. Ibig sabihin, guys, if I want to find the electric field at this point, okay, electric field at this point, yung electric field at this point, kung sabihin natin yung layo niya is R from my long wire, okay? So, yung electric field ko at that point, electric field ko at this point will be equal. Okay? Sabihin natin na puro R yung length niya. Okay? And from this point also to this point, kung ang layo din niya is the same, kunwari sabihin natin this is 1 cm, yung electric field ko at that point is the same as the 1 cm downward here. So, the same din po siya. Electric field ko at this point will be the same. Okay? Ngayon, sa Gauss's law po natin, importante po talaga ang tinatawag nating symmetry. At nakita ka na ng symmetry kasi nakita ka na ng same electric field at specific points ng atin pong infinitely long thin wire. Ngayon, once na nakita ka na nun, guys, you can actually draw what we call the Gaussian surface. So, for infinitely long thin wires, kita nyo naman siguro na at this point, yung electric field ko is pare-pareho. At this point, electric field ko din is pare-pareho. So, we can actually draw a cylindrical Gaussian surface. So, sabihin natin, cylinder po yan. Cylinder. Okay? And, I want you to remember na every time po na na gumagawa na tayo ng Gaussian surface, you find the direction of your area agad. For example, at this point, sabihin natin, kunwari, sa'yo nakaharap yung cylinder. Okay? So, ayan yung cylinder. Di ba yung area nito is going towards you? Okay? Going towards you. So, kung ito yung cylinder na nakatabingi, so it's going towards this. It's perpendicular to my surface. So, yan yung magiging area ko. So, at this point, yung area ko is going this way. Tama? So, this is 90 degrees from my surface. And if you remember, no, kapag po, ito yung area ko, yung electric field ko is going what? Upward or downward. So, no matter what, 90 degrees yung layo ng area ko dun sa electric field ko. And, yung 90 degrees na yun is actually my theta. So, yung theta nito is yung layo ng area ko sa electric field. Meaning, kung 90 degrees yan, and I'll find my cosine 90 degrees, then I will have 0, 0. Tama? So, bakit po natin kailangan yun? Dahil to find my electric flux, I have to multiply my electric field times my area times cosine theta. And since cosine theta is cosine 90, this is actually 0. So, yung aking electric flux is also 0 at what? At this point and at this point. So, wala akong electric flux dyan. Ang meron lang akong electric flux, probably, ay sa saang part. So, kung magdodrawing tayo ng area, I'll find my surface area here. Kukuha ko ng konting area dito. Diba? Yung area ko is going like outward also dahil lagi namang outward yung area natin. And 90 degrees from my surface. And anong mapapansin nyo sa electric field natin? My electric field is also going the same way, the same direction as my area. Meaning, if my electric field is parallel to my area, my theta is actually 0. And if my theta is 0, cosine 0 is equal to 1. So, in short, my electric flux for this wire would be, for this area, surface area, would be E times A cosine theta. And cosine theta is equal to 1, so magiging E times A na lang siya. Okay? So, yan po yung magiging electric flux ko sa isang infinitely long thin wire. So, ganito po yung magiging itsura niya. Dapat, hindi nga lang ganun kaganda yung akin, pero at least. Okay, anyway. So, ngayon, I want you to focus naman on this lambda. Sabi, yung lambda na yan, guys, is yung charge per unit length natin. So, lagay natin, lambda is equal to charge per unit length. So, itong charge per unit length na to, guys, ito yung charge density natin tinatawag. Ibig sabihin, ito yung distribution ng charge mo along that thin wire. Okay? Para kumuha ka lang ng part doon. Tapos ito yung charge per unit length mo. So, sa charge per unit length, nakukuha siya by, so from the description itself, charge, edi Q over per unit length. So, over, sabihin natin letter L, charge per unit length. Okay? So, lagay natin dito, charge per unit length is equal to lambda. So, mahalaga po yan kasi pwede po natin siyang gamitin doon sa magiging equation po natin. So, again, our electric flux is equal to my electric field times my area. Okay? Electric flux is also equal to Q enclosed, yung charge natin, net charge natin in an enclosed area all over the epsilon naught. So, epsilon naught is the permittivity of free space at meron po yung value. So, permittivity of free space, 8.85 times 10 raised to 12 coulomb squared per Newton meter squared. Okay? So, meron kang ganitong klaseng relation. Tapos, etong Q na to, guys, in case na walang given na Q, you can actually replace it with yung Q mo from this equation. Q would be equal to lambda times your length. Okay? So, pwede kong palitan yung Q ko na naandito. So, lagay ko yan. EA is equal to lambda L all over epsilon. No. Ngayon, ang kailangan daw natin ay electric field. So, pwede kong gawin po na electric field is equal to lambda L all over A times epsilon naught. So, by dividing both sides by A, mapupunta siya dito sa part na to. So, A times epsilon naught. Ngayon, tingnan mong mabuti. If i-analyze mong mabuti or hahati-hatiin mo isang cylinder, di ba meron siyang parang pabilog na part, dalawa yung pabilog na part na yan, at meron siya ditong um, parang rectangle na part. Di ba? Yan yung pagkaka iba-iba, sorry, yung partition ng isang cylinder. So, ngayon, etong length, yung haba nitong cylinder mo would be your L. Tama? So, wala tayong problema doon. Ang hindi mo alam is gaano kahaba tong width niya. Okay? Pero actually, alam mo talaga dapat yan. Bakit? Kasi, di ba yung width ng isang cylinder? Ito, yung isang cylinder is para lang siyang isang mahabang rectangle na binilog mo. Okay? Ibig sabihin, yung na-form ko na bilog is the circumference of my circle. Meaning, yung haba nito is yung circumference ng circle mo. So, ano ba circumference ng circle? Circumference ng circle is equal to 2 pi r. So, ibig sabihin, yung length ko din, yung width ko dito is also 2 pi r. No, now, I need my surface area. Yung area na nilalabasan ng electric field ko. So, to find that surface area, ito yun, guys. Di ba, ang pagkuha lang naman ng area ng rectangle is length times width. So, ang gagawin ko lang dito, to find my area is equal to length times 2 pi r. So, ilalagay ko siya dito, guys. Lambda L all over length times 2 pi r times epsilon naught. So, pwede ko makancel yung length ko. What do I have? Now, to find my electric field in an infinitely long thin wire, electric field is equal to lambda, the charge per unit length, all over 2 pi r times epsilon naught. That's all, diba? Okay.